NASA's rover just captured something no one expected, a strange, moving creature on the surface of Mars. For years, scientists told us Mars was a dead, empty world, covered in dust and rocks with no sign of life. But when experts studied the rover's latest images, one professor spotted something shocking. Could it be proof that life exists on the red planet? Tune in, because what NASA's cameras caught was so impressive, the president ordered them to shut down all missions to Mars. Digging through images from Curiosity, he claimed to have found what looked like insects and even reptile-like creatures crawling around the Martian surface. His observations were based on clear anatomical structures visible in the images, details that shouldn't be present if Mars were truly as lifeless as NASA insists. That's right, actual moving things, not just weirdly shaped rocks or optical illusions. If that doesn't make people question what NASA isn't telling us, nothing will. Before we delve into this, one thing is certain. What Curiosity captured is far more shocking than anyone expected. And this won't be the only discovery that will make you question everything. Rover analyzed hundreds of images, carefully studying the details that most would overlook. He pointed out various body parts that closely resembled known features of Earth's insects: segmented bodies, legs, wings, antennae, even signs of movement. These weren't just random formations in the Martian dust. They followed distinct patterns that suggested biological structures. Some of the specimens in the images appeared to have their heads turned, as if responding to their surroundings. One such creature measured approximately 20 inches in length, based on the scale from NASA's own photos. This wasn't some tiny speck. It was something significant, something that had structure, something that could not be easily dismissed. Rover was not looking at vague, blurry shapes. He was looking at what he believed were real, living organisms. The images provided even more compelling details. Some of the creatures, based on their positioning and the way light reflected off their bodies, appeared to be in motion. One insect-like form seemed to be flying, its legs extended as if caught mid-air. Another had a head and thorax clearly visible, positioned as if it had landed on the rocky terrain. One particular image showed a creature in flight, its wings spread wide, displaying veins and segmented patterns similar to those seen in earthly bees. The presence of these intricate features suggested more than mere chance or tricks of light and shadow. If Mars were truly a dead world, then why did these images show such undeniable complexity? And it wasn't just insects. Rover also identified what looked like reptile-like organisms. Some appeared fossilized, their remains preserved in the Martian dust. Others seemed fresh, as if captured alive by the rover's cameras. In one of the most startling images, a reptilian form had what looked like an open mouth. Inside, another, smaller, insect-like creature. This suggested an interaction between different forms of life, something that shouldn't exist if Mars were completely devoid of biological activity. These creatures weren't just there, they were engaging with their environment. They were hunting, they were moving, they were surviving. Despite the weight of this evidence, NASA has remained silent. Their official stance remains unchanged. Mars is dry, desolate, and devoid of life beyond perhaps a few microscopic organisms buried deep beneath the surface. But Rover's findings challenge that narrative. If there are insects and reptiles on Mars, then what else is there? What else are we missing? And more importantly, what does NASA already know that they aren't sharing? These questions linger, unanswered, as the space agency continues to release carefully curated images that conveniently avoid showing anything that might disrupt their official story. The implications of Rover's research go beyond just proving the existence of extraterrestrial life. If there are creatures living on Mars, then the planet must have an ecosystem, a food chain, a network of life that sustains itself despite the harsh environment. That means there must be sources of water, places of shelter, and possibly even a hidden underground world where these organisms thrive. The presence of wings suggests that some creatures can fly, which means there is at least some kind of atmosphere that allows them to do so. The presence of burrows indicates that the ground is soft enough for digging. These are not signs of a dead world. They are signs of adaptation, of survival, of life finding a way even in the most extreme conditions. If Romosa is right, then NASA staying quiet isn't just strange. It makes you wonder what else they might be hiding. One of the most chilling aspects of Romosa's findings is the possibility that NASA has known about this all along. It's hard to believe that an independent researcher was the first to notice something this monumental. The rovers have been taking high-resolution images of Mars for years, yet NASA has never publicly acknowledged anything remotely close to what Romosa has described. Either they are completely unaware of what their own images contain, which seems unlikely, or they are deliberately choosing to ignore or worse, hide the truth. If life exists on Mars, then that changes everything. The idea that humans are alone in the universe has been a cornerstone of scientific thought for centuries. If Mars is home to living creatures, then the universe is far more alive than we ever imagined. It's not just about what Romosa found, it's about what his findings suggest. If Mars has insect-like and reptile-like organisms, then what does that mean for other planets? If life can exist there in such a harsh environment, then where else might it be hiding? The implications extend beyond just Mars. They force us to rethink our entire understanding of biology and evolution. Life on Earth is adapted to specific conditions, but clearly that is not the only way life can exist. Mars, with its thin atmosphere and extreme temperatures, should be inhospitable. And yet, Romosa's images suggest that something has found a way to survive. Something is thriving against all odds. And if it can happen there, then it can happen elsewhere. It can happen anywhere. The idea of an underground world on Mars is perhaps the most compelling possibility of all. Some of Romosa's images suggest creatures disappearing into crevices, vanishing into shadows, as if they are retreating to hidden homes beneath the surface. This would make perfect sense. If life on Mars is anything like life on Earth, then creatures would seek shelter from the planet's harsh surface conditions. The underground could provide warmth, stability, and protection. What if entire ecosystems exist just beneath the ground, hidden from the rover's cameras? What if the real discovery isn't on the surface, but buried deep within the Martian crust? The thought alone is enough to shift everything we thought we knew about the red planet. NASA's silence on the matter speaks volumes. They continue to focus their public efforts on distant exoplanets, hypothetical water sources, and theories about microbial life that may have existed billions of years ago. But what about now? What about the creatures caught on camera today? Why is there no discussion about the images that seem to show movement, patterns, structure, clear indications of something beyond mere rock formations? It's easy to dismiss one or two images as tricks of light or pareidolia, the human tendency to see familiar shapes in random objects. But Romosa didn't just find one or two. He found numerous examples, enough to suggest a pattern, enough to suggest something real. Even if NASA refuses to acknowledge Romosa's research, the evidence speaks for itself. His analysis is based on observable features: wings, legs, segmentation, eyes. These are not ambiguous smudges on a screen. They are distinct anatomical structures. They match the features of known Earth organisms. They follow biological rules. They exhibit behavior. If these images had been taken on Earth, there would be no debate. They would be immediately classified as living creatures. The only reason they are questioned is because they come from Mars. And that is exactly why they shouldn't be ignored. Curiosity has sent back so much data, but instead of clear answers, we just have more questions. NASA's Curiosity rover has been rolling around Mars for more than a decade, sending back data that's supposed to rewrite what we know about the planet. But let's take a step back and really think about it. What has it truly uncovered? A big, dry landscape filled with old rocks? Yes. Signs that Mars might have once been a little wet? Sure. Proof that there was life? Not exactly. And yet space agencies keep talking about habitability as if they're on the brink of finding something huge. Are we really learning groundbreaking information, or are they just stretching out the mission to keep the excitement alive? Curiosity launched back in late November of the year 2011, a time when smartphones were just getting smarter and social media was taking over daily life. Less than a year later, it landed in Gale Crater in early August of 2012. A big deal, right? It had a ton of fancy tools, a complicated landing system, and was supposed to be the next giant leap in Mars exploration. The goal? To find out if Mars ever had the right conditions to support microbial life, especially by looking at water-related minerals and atmospheric clues. But here we are, over 10 years later, and we're still asking the same questions. NASA loaded Curiosity with instruments that sound impressive. A laser that zaps rocks, a camera to look at them up close, and a device that sniffs out gases. But at the end of the day, all it's really doing is driving around, drilling holes, and sending back pictures. The rover also carries a power system that runs on decaying plutonium, essentially a tiny nuclear battery. This means it doesn't rely on sunlight and can keep going even in the darkest Martian nights. That part is cool, but how much longer can it really last? And more importantly, what's left for it to discover? One of the first things Curiosity found was proof that water once existed on Mars. There were ancient riverbeds, minerals that formed in water, and patterns in the rock that hinted at a time when Mars wasn't just a dry, lifeless wasteland. NASA took this and ran with it, talking about habitability as if this was the first step in proving life once thrived there. But hold on, just because a planet had water doesn't mean it had life. Earth has endless lakes, rivers, and oceans, but not every puddle is teeming with microbes. If anything, Mars' ancient water dried up billions of years ago, leaving behind dust and disappointment. Over time, the rover has covered a lot of ground, literally. It has climbed hills, crossed dunes, and squeezed through rocky paths that would challenge any off-road vehicle. Along the way, its wheels have taken a beating, with holes and cracks forming due to the rough Martian terrain. Engineers have tried to adjust the way it drives, but wear and tear is inevitable. The big question is, how much longer can this thing keep going before it just stops moving? One of the more interesting finds came when Curiosity detected traces of organic molecules in rock samples. This sparked excitement. Organic compounds are essential for life. But again, let's not jump to conclusions. These compounds can also be formed by non-living processes, and just because something is organic doesn't mean it came from a living creature. Plus, the levels of methane, another potential sign of life, have fluctuated in ways that are still not fully understood. The bottom line? NASA keeps teasing the possibility of something big, but after all these years, it still remains just that, a possibility. Curiosity's mission has also helped pave the way for other rovers. The design of Perseverance, which landed in early 2021, was heavily based on Curiosity. But Perseverance has a key difference. It's collecting samples that might one day be sent back to Earth. Meanwhile, Curiosity is still wandering around, taking pictures and analyzing rock dust, while the focus shifts to its newer sibling. It's almost like a hand-me-down rover at this point. Despite its age, Curiosity is still sending back data. Every now and then, NASA announces a new discovery, like finding ripples in ancient lake beds or identifying new types of minerals. But does any of this actually change what we already knew? Mars was wet billions of years ago, then it dried up, the atmosphere changed, and now it's a cold, barren desert. These aren't shocking revelations anymore, they're just minor details filling in the gaps. The real question is, How much longer can NASA keep milking this mission? Curiosity was designed for a 2-year mission, yet here we are more than a decade later, still talking about it. The rover's findings have been interesting, sure, but they haven't been the game-changing discoveries we were promised. Scientists keep analyzing old data, looking for any tiny detail that might justify keeping the mission alive. At what point do we admit that we've learned most of what we're going to learn from curiosity? Even if we find life on Mars, staying alive there is a much bigger and more dangerous problem. The idea of people living on Mars sounds exciting, right? A brand new world, fresh start, big dreams. But hold on, it's not just about planting a flag and calling it home. Mars is nothing like Earth, and that's where the trouble begins. Before we dive in, let's just say this. Surviving there isn't going to be easy, and maybe, just maybe, we're getting ahead of ourselves. First things first, Mars is basically trying to eliminate you at all times. Its atmosphere is mostly carbon dioxide, which means if you step outside without a spacesuit, you'll suffocate instantly. The air pressure? Almost nothing. Your blood would literally start to boil in your veins without protection. And if that's not bad enough, the temperatures can swing from colder than Antarctica to a slightly warm afternoon in the desert, all in a single day. You like sunshine? Great. Except on Mars, it comes with a side of deadly radiation. Without a thick atmosphere to block cosmic rays, your chances of developing serious health problems skyrocket. And let's not forget about gravity, or rather the lack of it. Living in low gravity for long periods messes with bones, muscles, and possibly even the heart. Not exactly the dream vacation spot. Let's talk dirt. Martian soil isn't just dry and lifeless, it's toxic, packed with perchlorates, which can mess up human thyroid function. It's the kind of stuff that needs serious cleaning before we can even think about growing food. So forget the whole plant a garden and live off the land idea unless you're ready to deal with some major chemical problems. Water? Yeah, there might be some frozen underground, but mining it isn't exactly a walk in the park. You'd need specialized equipment just to get a few drops. And without water, there's no drinking, no farming, no life. Now, assuming we even get there in one piece, we have another mountain to climb. How do we stay alive? A trip to Mars takes anywhere from 6 months to nearly a year, and it's not exactly a smooth ride. The human body starts falling apart in space, thanks to zero gravity and high radiation. By the time astronauts land, they're physically weaker. Their immune systems are shot, and their bodies are screaming for help. Oh, and let's not forget, once they're on Mars, they can't just hop on a plane back home if something goes wrong. They're stuck there until Earth and Mars align properly again, which takes about 2 years. 2 years of trying not to die on a barren, frozen wasteland. Sounds fun, right? Power is another nightmare. Solar panels? Good luck with the dust storms that can last for months and block out the sun completely. Nuclear power? Maybe, but setting up a reactor on another planet isn't exactly simple. And let's be real, relying on Earth for supplies isn't a long-term plan. Mars has nothing, no oil, no coal, no easy-to-reach resources, so whatever we need, we either bring or make from scratch. Then there's the little issue of keeping people sane. Imagine being locked in a small metal box with the same few people for years, knowing that outside is instant death. No fresh air, no open spaces, no escape. Isolation and stress would be brutal. On top of that, every message to Earth takes about 20 minutes to send, and another 20 to get a reply. If an emergency happens, there's no quick help coming. Psychological breakdowns? Almost guaranteed. And who makes the rules? Is Mars going to be a democracy, a dictatorship, a lawless frontier? Nobody knows, but history tells us that humans stuck together in tough conditions don't always play nice. Still, some people want to go and a few big names are pushing for it. NASA has plans, but they're taking the slow and careful route. First back to the moon, then maybe Mars. SpaceX, on the other hand, is talking about sending huge ships loaded with people, aiming to build a city. But even with all the money and tech in the world, they're up against a planet that does not want humans there. China, meanwhile, is also looking at Mars, but details on their plans are murky. The bottom line, nobody has cracked the code for how to actually make it work long term. And then we get to the ethics. Should we even be trying to live on Mars when Earth is falling apart? We're talking about spending billions, maybe trillions, on a risky adventure, while problems like climate change, poverty, and disease rage on at home. Is NASA hiding the truth about life on Mars, or did the rover truly capture something extraordinary? Tell us what you think, and remember to like and subscribe for more.